Hi folks, Dan here. Since the GoToMeeting was a bust, I thought I would just do this as a little video. So I'm using Camtasia, so I have to remind myself not to move the screen around. And you can play this video and then follow along with the same sort of, if you use that .sav file that I shared with you the other day, you can go ahead and do that. Okay. Important part here is data view, variable view. Data view, this is where the numbers go. Variable view, this is where the characteristics of the data are set. Okay, important part here is the name. You cannot have any illegal characters. It has to be like back in the old DOS days. So you can't have spaces, for example, or it's going to tell you there's an illegal character there. Okay. You can't have any spaces. You can't have any backslashes, no ampersands. But we're just going to call this one sample. And then over here, you can, on the label, you can actually put any legal characters you want in that. So, all right. The type is numeric. For the most part, we're going to deal with numbers. But as you'll see, there's a lot of other options too. Scientific notation for those cats doing astrophysics and that sort of stuff. You can set the decimals here. You can go up and create decimals if you want. We'll save it on that. The column width is how wide you want the column. And then as you'll see here in this is levels of measurement. So in your studies you have nominal, ordinal, interval, and ratio. Well, here we just have nominal, ordinal, and scale. So scale would be both ratio and interval level data. We just call it scale. Alrighty, so let's get back to data view. So here we have 10 numbers, and one of the first things that we want to learn is how to get descriptive statistics. So let's analyze, descriptive, and we'll just put that over there. So that's how we get the variables over there. You probably already figured that out. And okay, so there's the descriptive statistics. It tells us one sample. It has a mean of 7, a standard deviation of 3.265, minimum and max. Okay, you don't want to save that, so let me do that again. Analyze, descriptives, and here you can set the options. So minimum and max, it's a good way to, if you have a lot of data, to make sure you don't have any coding errors. So if your numbers can only go up to 12 and you got an 86 in there, then you know that that's not cool. Okay. All right. So there we go. All right. So you've done your, there's descriptive statistics, and we'll do some more of them. All right. The first thing I want to show you is how to do a one sample t-test. In a one sample t-test, we have a sample, and we're going to try to compare it against some known value. So what I have here is data from 20 nurses. These nurses are all women, and they're between the ages 35 and 45, and this is their resting blood pressure here. Okay, well, I know, because let's say that there is actually norm data out there, I know that the population resting systolic blood pressure for women of that age cohort is 120. And what I want to know is if this population is acharacteristic. So the statistical question we're asking is, what is the relative probability that any difference in mean blood pressure between our sample and the population norm values is a byproduct of chance itself? Okay, so analyze one sample t-test. There it is right there. Okay, resting systolic. Okay, and here's where I put in the population value. So I said that the norm for that age of those women is 120, but here I have 20 nurses, and here's what I get. Well, we see that their resting systolic blood pressure is 130, and that surely is different than 120, and we ask ourselves, is it statistically different? Well, here's the T, and here's the two-tailed value of its difference. So the nurse mean blood pressure is statistically unlike the normal population. There's some stress puppies. Okay, so once again, it's analyze, one sample t-test, pull it over, and then we put in the test value, which would be the norm. So there you have a one sample t-test. Okay, part of what we need to know about SPSS is when we need stacked data and when we can have unstacked data. Okay, the next statistic we're going to do is a dependent samples t-test. And you'll recall in a dependent samples t-test, we have subjects who are going under multiple. We're collecting data off of the subjects multiple times. Okay, so here I have 10 Indian gods, and they're at one point going to experience a drug and another experience a placebo, and let's just say that this is a measure of relative pain. Okay, and so what we're asking is do their pain values differ under the placebo condition or under the drug condition? Again, it's analyze, compare means. We have a paired sample t-test. Okay, and we put the placebo in there, and then we put the drug in there. Okay, we click on options. We don't really need that. The p-value gives us the confidence interval already, and say okay. And here's what we get. So this is again dependent sample t-test, same subjects, both taking placebo and a drug, and we see that the mean pain level for the placebo is 5.9. The mean for the drug condition is 4.50. So we know we have a difference in the mean, and the effect is coming out in favor of the drug. But what we have to ask is that statistically significant? And we can go down here and we find the paired sample. There is the t-value. We have 9 degrees of freedom, and it's statistically significant. Okay, so that is a paired sample t-test. All right, so now we're going to do an independent sample t-test, as we would normally do inside of our research projects. We would, probably list our subjects, give them a subject ID, and now I have to set this up. Most things, only in repeated measures are you allowed to do unstacked data like we've done here. We're comparing column against the column. A lot of the statistics we have to do it as a stacked situation here. Okay, so here's your subject ID. Now let's go to variable view, and we'll see that a group is a string. It's just a name. Okay, and it's here, so in the label I can put the long name for it, but it's inside of this string variable where I have to declare its properties. So let me remove that, and I'll show you. So I have to say for the number 1 that I'm using in the group ID, that is placebo. Okay, and 2 is drug. So I got to define that. Okay, there we see it here. You click on it. And let me just double check here. Yeah, so group 1 is placebo. And I'm using exactly the same data as I had here. So now I'm treating it as though it is not a dependent sample t-test. So we have created a group variable, and now I've put the data in. Now we're going to set this up, analyze this as a one sample t-test. Okay, compare means, independent samples t-test. Okay, and the test variable is this reports of pain. Okay, little ruler tells me that it's a ratio level number. Okay, and then I have to put the grouping variable here. Okay, so I find the group membership. Okay, and notice it's not giving me a chance to say okay. I can't do okay yet because I have to define the groups here again. Okay, so group 1, I've told it that it's being coded as 1. Group 2, I've told it it's being coded as 2. All right. And here we have the one sample t-test. So the placebo has higher pain, 5.9 on a pain scale. Drug, 4.50. We come down here, and for independent sample t-test, we report the T. Here is the T, and it's no longer statistically significant. Well, it was the same exact data that we had for the dependent samples t-test, but now with the independent samples t-test, it's no longer statistically significant. So part of your assignment in working with your statistics is to come to understand why that is no longer statistically significant. What is the answer there? Okay, so that is an independent samples t-test. Okay. Before I go on, let's take a look at this output once again. So here we have a two-tailed test. A two-tailed test is you don't know which way the hypothesis is going to go. And as you learn painfully, that's completely a chump move. We declare strong hypotheses. We declare the null and the alternative hypotheses. We state what we think we're going to happen. We connect it to theory and we test it. So how you get a one-tailed test out of this is you actually have to divide this number in half to get a one-tailed test. So it would be 1.2.35. So even there, it's not statistically significant. Okay, so independent samples t-test, that's behind us. Now, let's do our first correlation. Now, just to point out, because I know there's been some confusion and it's warranted. There are two different kinds of statistics. Statistics that look at the differences between means, and then there are the statistics that take a look at how one set of data covary with another set of data. Okay, the comparison between means are called point estimators. Okay, and here's Julie's data, where she did for her the total sums of squares, and she created two vectors of data. One was the medications that the patients were taking, and a number is the number of falls. So let's just use her data and do our first correlation. So we can go analyze, correlate, and it's bivariate. we won't do partial or distances in this class. Well, I might do a partial later on, but let's just do bivariate statistics. Okay, and here we're going to take number of meds taken, and we're going to correlate that with Julie's numbers of falls. We're interested in a one-tailed test because Julie is not a chump. She would say, declare in strong voice that medications are related to falls. And that's pretty much it. So here we go. Get our first correlation. Let me drag it up here. And we find out that it's correlated. This is R of 0.402. This is an R. So if we're trying to ask how much variance in falls can be accounted for by the number of meds, you already know that you need to square that number. So 0.402 squared is going to be something like 0.16. So medications only accounted for just a little over 16% of the data, and we can see here that this is statistically not significant, 0.125, and that there are there's 10 subjects in the data. Notice that the data is duplicated down here, so we read it off the angle. Okay, so that's a correlation. We could get that same sort of by looking at this as a regression. So regression is just correlation, but it puts in we also get the algebraic line that goes with it. So here we put number of falls, a number of meds, we put in independent, and just say okay. And once again, it would tell us, we do it in regression, it'll give us the R, and it'll also square it for us. And adjusted for chance, it's even smaller yet. Okay, and once again, we see that it's not statistically significant. So that's regression. Okay, folks, you know how to get descriptive statistics. So again, that's analyze, descriptive, and we can put any of the variables that we want in there. Julie's number of falls. Okay. Mean and minimum, maximum, and mean standard deviation. So you know all that. Okay, last thing I want to show in this little tutorial is how to plot data. I have run a statistical business for almost 30 years now, and it's just really important to actually plot the data so you can take a look at it. So what I want to do is graph Julie's data. So we know that there was a relationship there, but the correlation was very small. And so let's plot her data. So we go use scatter dot plot. We'll just use a simple scatter. Okay, and put Julie's number of falls in the x-axis, number of meds in that axis, and we can just say okay. And it's going to graph it for us. Okay, so we knew that there was not a strong correlation there, and that's what we see. We see plenty of scatter here between number of falls and number of meds taken. You can also put in a line of best fit in there as well. So you just double click on that, and then this chart editor will come up, and then you can just say, give me the line of best fit. And there it draws the line of best fit for Julie's data. So fool around with that a little bit, okay? Have some fun. I just downloaded, my subscription expired for for my Mac, but I just downloaded the 14-day version of that. I should have just mentioned to folks that you can download the 14-day version and probably do all the stats you need for this course. But if you have a regular version, it'll give us more time to explore more things. So okay, I'm closing off here. See ya.